So we discussed about the red shift and the blue shift and what all these things mean. Okay. So finally, after studying all these things, red shift, blue shift, we discussed that the universe is expanding, right? So the universe is expanding because all the galaxies, they are giving out, almost all the galaxies, they are giving out the light with redshift. So that will mean that the galaxies are moving away from us. Okay, so all the galaxies, they have this clear pattern, that is they emit this light in redshift. Okay, so the further away a galaxy is, the greater the redshift, and therefore the faster it is moving away from us. Okay, so there are two things we need to remember. One is all the galaxies, they emit the light with redshift, and the further away a galaxy is, the greater the redshift is, and therefore this means that they are moving away from us in a very faster way, in a faster, okay, the speed is greater. Okay, so this will conclude that the universe is expanding, okay, according to the theory. At one point of time, the universe was, you know it was a concentrated part, that is, it was fused together. Okay, and after a violent explosion, all the ingredients, all the energy, the particles, whatever, it just came out, and this event is known as the Big Bang. Okay, so altogether this whole theory is called as the Big Bang theory. Okay, so I think you are very clear about this. If you have any doubts, you just ask me. We also discuss about the Dove model, right? The Dove model, which gives us again a very clear picture about how this universe it got expanded, and how the spaces came in between the galaxies or other heavenly bodies. Okay, any doubts you have, you can ask me right now regarding the Big Bang theory. So according to this theory, from the rate of expansion, the scientists, they have calculated that the universe started from a single point about 13.8 billion years ago. Okay, so this is just an estimation. Okay, so what is the age? If you get a question about the age of the universe, you can write this estimated count, 13.8 billion years ago. Okay, so this number is a very standard one, which is being you know uh, showed and written in many books, okay, by scientists, by researchers. You can google it out. Okay, this 13.8 billion years ago, this figure is very standard one. Okay, so we also discuss how to find this, the uh, how to that is how to uh, find out the speed of the velocity of the galaxy using the Doppler equation. Okay, today we will not discuss about the problems. Okay, rather we'll discuss about another topic, which is known as the cosmic microwave background. Okay, so in the 1960s, the scientists, using radio telescopes, they detected a low energy, a low frequency. It's very important. These two are keywords: low energy, low frequency, electromagnetic radiation. EM is electromagnetic radiation coming from all the parts of the universe. Okay, it didn't come from a specific point. It didn't come from a galaxy or a solar system or so on, but it came randomly from all the parts of the universe. Okay, so this background radiation is in the microwave range. You know the range, there are multiple ranges in a electromagnetic wave where you have parts, correct? Like the visible light, like the microwave, radio waves. You have studied this in the electromagnetic spectrum chapter. Okay, so this background radiation, it falls on the microwave range, and the name which was given to this was the cosmic microwave background radiation. Okay, so this cosmic background radiation, microwave background radiation, is another evidence for the Big Bang theory. Okay, so the first evidence is the redshift. Okay, now the second evidence for the Big Bang is the CMB, the cosmic microwave background. Okay, so in 1984, the Big Bang theory predicted that this radiation should exist as a relic of the thermal radiation from the original Big Bang explosion. That is, right after the Big Bang, an enormous amount of thermal radiation or heat energy, it came out. Okay, and it is present in the whole universe, and that is what we are receiving now. Okay, and that is what was received in the radio telescopes. Okay, so the theory also predicted that the observed wavelength of the radiation today would be much greater than the wavelength of the light emitted shortly after the Big Bang. That is, immediately after the Big Bang, the wavelength of the light, okay, was, shorter. Okay, as over time, that is, as time went on, over time the wavelength started to become, larger, a greater wavelength. Okay, so they said, the researchers, the scientists, they said that this is due to the expansion of the universe, which stretches the wavelength of the light. Okay, so this gives us the evidence that the universe is, again, it's expanding. Okay, right now the scientists, the researchers, they are raising a question. What is that question? They're asking, will the universe continue to expand? Okay, so this is the question which they are asking about. Okay, so see, basically there is a force which operates in the universe. This force is gravitational force. Right from the beginning, since the event of this Big Bang, gravity existed. This gravity, it brought all the particles, the dust particles, it made them to fuse together and form galaxies, stars, and so on. Okay, so gravity always existed from day one. Okay, so gravity has an effect of slowing down the expansion. Okay, so scientists, they believe that one day this expansion will gradually slow. It will become slow. It will slow down, and the process of expansion, it will reverse, pulling back all the matter, okay, to a single point. Okay, so this theory is known as the Big Crunch. That is, at one point of time, the gravitational field strength, or the force, whatever it is, it will be larger, it will become greater, and this will allow all the matter to fuse together, which will again, it will come back to the single point, right? So it will come back to the same conditions like how it was there at the time of the beginning of before the Big Bang. Okay, this is known as the Big Crunch. Okay, and they say that the rate at which the expansion of the universe slows depends on how much mass there is in the universe. Okay, I think you remember the Newton's theory, which says, it speaks about you know the gravitational field strength. The gravitational field strength depends upon the mass of the object, and also the distance between two bodies. If they are, you know they are attracted together, it depends also between, the distance between these two bodies, right? Okay, so the greater the mass, the more the expansion of the universe will be slowed down. Okay, so again, it depends upon the mass. Okay, again, it depends upon how many bodies they are present in the universe, and how huge, massive they are. If they are massive enough, then the gravity will be more, then this crunch can happen. Okay, so in 1988, observations of a very distant galaxy made by Hubble Space Telescope. See, this Hubble Space Telescope was named after Edwin Hubble. He was a scientist, uh, an astrophysicist. Okay, so this telescope showed that the expansion of the universe had previously been slower. It is Previously it was being slower, and now it is accelerating. It is faster. Okay, so even this suggested that the expansion of the universe, it's not slowing down, but it's accelerating. Okay, but scientists, they're not able to explain this phenomenon. Okay, they have a theory that there is another force and another energy in the universe that is causing this acceleration. Okay, so there are two forces. One is the gravitational force, which is slowing down the expansion of the universe. The other one is the dark energy, which we're going to discuss. This dark energy, it's allowing the universe to expand, to and to accelerate the expansion rate. Okay, and this energy is nothing but the dark energy, because they cannot see it or they cannot detect it by any means, so they have named it as dark energy. The exact nature of dark matter is not known, and nobody has ever since they have detected directly with an instrument or so on. Okay, but they believe that this dark energy do exist. Okay, so we have come to the end of the presentation. We have come to the end of the chapter. Alhamdulillah. So if you have any